Hello, everyone, and welcome or welcome back to Cloud Native Wednesdays, as I like to call it. My name is Erika, and I am the Program Manager at MicrosoftReactors.com. Today, we are going to continue with the second episode of the Championing Azure Collection series, Cloud Native track. The Championing Azure Collection series is aimed to provide the necessary skills in Azure and is perfect for those that are early in their developer career. The series focuses on three Azure functions: AI and machine learning, cloud native, and DevOps. Throughout our hands-on workshops, we will introduce the basics of Azure and demonstrate what the platform is capable of. For the next 5 weeks, on Wednesdays, we have beginner content in cloud native. But before I carry on, I would just like to say a very quick word about Microsoft's Code of Conduct. We all come from different backgrounds, but we are all here to learn. So just please be aware of each other and be welcoming and respectful. Thank you. But now, let's move on to the reason why we are all here today. And let me introduce you to our speaker today, Alan Smith, whom you may have met last week at the Introduction to AI and Machine Learning session, if you follow the AI track as well. For those who don't know Alan yet, well, you're in luck to meet him today, as he's quite a mastermind, believe me. For a starter, he's one of the top 10 developers in Sweden, has been an MVP for over 15 years in several emerging technologies, and is currently the MVP of the year in Microsoft Azure. Alan has more than 25 years of experience within IT and has worked in developing a wide range of projects and technologies for many companies in several different countries and cultures. Well, today I am very happy to welcome him back to this series, where he's going to introduce us to the event-driven architecture. This session will be very heavy demo intensive, where we will highlight the platform as a service in Microsoft Azure that can be leveraged to form the foundations of cloud-based event-driven architecture. We will cover the capabilities of messaging and eventing technologies in detail and provide guidelines on selecting the appropriate service for a given scenario. We will also demonstrate how these services can be integrated with other Azure services to develop a cloud-native, serverless, event-driven application. This session is going to run for about 45 minutes, with some time at the end with some Q&A. But I encourage you to ask your questions during the session. Alan will try his best to answer them as we go. Now I think I've spoken enough, so let's bring you here, Alan. There you are. Hey, hello, and
Hi.
Thank you for joining us today, and welcome back.
Yeah, it's good to be back. Thank you.
Yeah, I'm looking forward, very much looking forward to today's session. So yeah, I am just going to put myself in the back. So it's all you. I see you in about 45 minutes, but I am here if I'm needed at the background. Okay?
Great. Thank you very much for that.
Yeah. Bye.
Yeah, so what I'm going to talk about tonight, or whatever it is in your time zone, is event-driven architecture. And next week, there's going to be a session where we're talking about serverless architecture. And serverless architecture is really going to be about the components, the services that we integrate with, whereas event-driven architecture, it's going to be about the plumbing, how we get packets of data, which can be events or can be messages between these different systems. So we're going to be looking at highlighting on three different technologies or services that we've got within Azure. We're going to be looking at the Azure Service Bus, Azure Event Hub, and Azure Event Grid. And I'll be talking a bit about when to use what, and I've got some demos that I can fire up in Visual Studio to highlight those technologies. So a bit about myself. I describe myself as a developer, trainer, mentor, and evangelist. I love writing code, so I'm happiest working in Visual Studio. I am currently delivering training courses in Microsoft Azure and machine learning, and I'm also working with Pluralsight courses. I'm currently updating my Azure Service Bus course for Pluralsight, and I like looking at new technologies and evangelizing those technologies. Right now, my main goal is to try and get people in my company to start programming in Python and working with machine learning solutions. So that's one technology that I'm exploring. As Erica mentioned, I do a lot with the community. We've been running the AI Burst conference, which we hosted at Reactor Stockholm a few weeks ago. And we're planning on running the AI Burst conference sometime in the summer, provided we get rid of these dreaded restrictions that are locking us all down at the moment. I usually travel around and present at conferences, but I'm usually sat here in my studio delivering conference sessions from home. But hopefully I'll be on the road again, getting out to conferences again. I also like to put my stuff on YouTube, so I have quite an active YouTube channel here at Cloudcast, which you're welcome to subscribe to. So some of the demos that I've been doing and will be doing are appearing on this YouTube channel. If you'd like to take a look at that. Okay, a bit about my company. We're based in Stockholm, Sweden, and this is what Stockholm, Sweden looks like. Last week, I discovered that many of the actual viewers were coming from different countries. So this is my hometown, and this is from my living room around about lunchtime. It's usually dark most of the time in Stockholm, Sweden at this time of the year. So we do get a few hours of daylight, but when we do, it's pretty cold and snowy and icy. We do get very nice summers though, and people are out paddleboarding and swimming in the lake that you can see there. So what I'm going to be talking about is event-driven architecture. And I like to have a definition of, what an event is. And also eventing and these technologies is very similar to messages and working with a message-driven technology. Very similar technologies. So the way that I kind of differentiate between messages and events is, suppose you've got a taxi service like Uber and you've got a mobile app where people can request taxis for pickup. And this is the application that you've got developed in Azure, and you're using a bunch of Azure services. These are the icons for the Azure Queue, the Azure Service Bus, the Event Hub, and Event Grid. And you're going to be working with messaging and eventing. So the customer is going to request a taxi, and that's going to go into your infrastructure, and that's going to result in packets of information being sent out to the nearest taxi that's free, asking them to collect a passenger. You're then going to get a confirmation saying that the taxi is on the way, and eventually you're going to get to your destination, and there's going to be a payment, and you're going to process that payment on your mobile device. Now, I'd say that all of these things I've put in purple, these are, critical to the running of the business. If we lose even 1% of the request taxi messages or the collect passenger messages, our customers are not going to be satisfied. If we lose 1% of the payment or these pay transactions, then the owners are going to start losing money. So these are really critical to the running of the business. Then we've got things like the taxi's location and the taxi status, which is going to be broadcast, say, every 10 seconds from a taxi. And also, you can see the taxi location in a little map when the taxi is driving to pick you up. And I would classify the purple things as messages and the green things as events. What happens if the car drives through a tunnel and you start to lose a few of these my location and status messages? Well, it doesn't really matter because the taxi comes out of the tunnel and you can pick up the new location. If the position is being updated only once a minute instead of every 10 seconds, it's not really a problem, even though you're losing a vast majority of these packets of data there. So when you're designing systems, you kind of want to think about, are we going to use a messaging technology or are we going to use an eventing technology? And we've got these 4 different technologies. We have had, since Azure was announced in 2008, October 2008, we've had storage queues. Now, there's nothing wrong with storage queues. They're very basic. They're very simple. They use a REST-based protocol. They give us quite good performance, about 2,000 transactions per second on a queue. Really easy to work with. I'm not going to really talk about storage queues because we have service bus queues, which are also very, very inexpensive to use. They are slightly more complex to use, but they support the advanced message queue protocol. They support enterprise class publish subscribe messaging. They provide additional features like sessions, dead lettering, duplicate detection. And to be honest, if you're building a messaging solution, you really want to be having these capabilities like dead lettering and duplicate detection, maybe message sessions as well. So it's good to consider Service Bus as being the first choice when you're working with messaging applications. Then on the eventing side, we've got Event Hub, which is really used for telemetry and telemetry ingestion. And this can handle millions of events per second. Halo 4, the Xbox game, was the actual prototype project, the first project to be ever built on event hubs. And I think they were doing about 250,000 events per second from the telemetry of everybody playing Halo 4. And that was on launch day when the actual system went into production. So you can build very high scalable telemetry scenarios. Service Bus, to about 2,000 message operations per second on a queue. You're not going to get that working in gaming telemetry for a mobile game. So this is built for really high volume telemetry. Then we've got Event Grid, which is built for real-time events. It provides great integration with many other Azure services, and it also supports publish, subscribe eventing. So in the demos, I'm going to be focusing on Service Bus, Event Hub, and Event Grid. I'm going to try and crack through this. If it feels like I'm going through the slides really quickly, it's just I want to spend most of my time on demos, and I'm sure you really want to see me in Visual Studio rather than me playing with and talking about PowerPoint slides. So a bit about the Service Bus. Within something called a Service Bus namespace, we can create a queue and we can create a topic. And within the topic, we can create things called subscriptions. And it's the topics and subscriptions that give us the publish subscribe architecture. So if I'm working in a system and I'm working with point-to-point messaging, you have an application sending messages, an application receiving, and you've got a queue. As things get more complex and you have more applications, you may end up doing something like this. So here the application has got to send a message to this queue or this queue or this queue. You've got lots of routing logic in the sending application, and getting messages routed is a challenge. If you decide to add another system that's going to be processing orders, for example, then you've got to modify the sending application to decide whether it needs to send to that fourth system or not. With publish subscribe messaging, the sending application just sends a message to a topic, and the topic handles all of the routing out to these different subscriptions. And you can put filters on these subscriptions to decide whether you subscribe to the messages or not. So first demo, I'm going to look at publish subscribe messaging. So I'll bring up this instance of Visual Studio. And this is one of the first things I ever built on the Service Bus. It's related to order processing. So what I'm going to do is to actually start the application running. And what it's going to do is to create a topic, which is called orders. And then it's generating, as you can see, a number of subscriptions within that topic. So I'm going to go to the Azure portal. And if I go to the Service Bus that I've created, which is this one here, we can go to the topics. And you can see that we've got this orders topic. And within the orders topic, we've got these subscriptions created. You can see that none of these subscriptions have any messages on them. They're all empty. If I go back to the portal, to my console application, you can see that when I'm creating a subscription, I'm specifying this filter. So for all orders, I'm not specifying a filter, but for the USA orders, I'm saying if the region is equal to USA, then we subscribe to that message. And I've got one with a region is equal to the EU, one with a region is equal to the UK. And then for large orders, if the number of items is greater than 30, then they're going to go to that subscription. If they're high value orders, more than $500, then they go to that subscription. And then for the people with loyalty cards in the USA, if loyalty is equal to true and the region is equal to USA, then that one is going to subscribe to it. So what I'm going to do is I'm going to send 5 messages to that topic. And you can see here the name of the order that I'm sending, the number of items on the order, the value of the order, the region, and whether they've got a loyalty card or not. And if I refresh this view here, you can see that all 5 messages went to this all orders subscription, and EU orders got 1 message, high value orders got 1, large orders got 2, USA orders got 3, and so on. So here, the topic and the subscriptions through the actual filters, if we look in this subscription, we can go in and look at the actual filter. And you can see it's saying there, if these properties are true in the message header, then the message is going to be routed to that particular subscriber. So this gives us a very easy way of distributing messages and working with pub-sub architecture. It's very simple to build a solution like that. And then I can receive the order messages. So there's 5 order messages coming from all orders. We've got 1 coming from the EU orders, 1 coming from high value, 2 from large orders, and this one has more than 30 items, and this is more than $500, and these each have more than 30 items. And we can see here that we've got 1 going out to the loyal customers, and 1 going out to the UK, and 1 going out to the USA. So for each message that we publish, a copy of that message is sent to every subscriber. So you can see that this loyal customer, this one here, is going out to this subscription here. It's going out to this subscription here. And it's also going out to this subscription here, because in that case, it matched 3 of those subscription filters. Okay, drop back to the slides. And I mentioned when choosing the service bus instead of choosing Azure storage is these enterprise messaging features. I really wish I had more time. Maybe in one of the advanced sessions, I'll go into a deep dive on the service bus. But we've got the AMQP protocol, which is a TCP-based, much better performance than using an HTTP-based queuing protocol. We've got also AMQP is open source, so Java applications will support it. C applications with an AMQP library will support it. We've got things like dead lettering, publish subscribe messaging, as you've just seen, message sessions, duplicate detection, message expiration, and so on. And all of this stuff you've got on the service bus, whereas the storage queues has quite a basic and limited functionality. So to demo some of these more advanced features, I've got this scenario here. So this is simulating a checkout at a store where we've got a radio frequency identification device reader. And RFID is kind of like if you've got, keys and you use kind of a key tab to get into your door at work. That's an RFID tag. And in some stores, they have these things on products. So the checkout can use RFID tags. Now, when you're scanning the tags in the basket, there's a high proportion or high likelihood that you're going to get duplicate tag reads. So you're going to read some of the tags 2 or 3 times as you're processing the order. And you don't want those items to be appearing 2 or 3 times on the bill, because you're going to be charging the customers too much money. They're not going to like that. So filtering out duplicate detection is something that we can also do using the service bus. So I'm going to jump back to Visual Studio. And this is a simulation of the RFID checkout. I'll start this application and basically talk you through what's going on. So the order is going to be at a sports shop, and it's stuff for 2 children to play a ball game. So there's a ball, a whistle, 2 bats, 2 pairs of gloves, 2 caps, and 2 shirts. And there's 10 items there, and the total value is 98.86. So what I'm going to do is to press enter to scan the tags, and we're simulating duplicate tag reads here. So we got 18 tag reads, and in the receiving application, we got 18 messages received. So we're billing the customer $178.70 for 18 items. Now, this isn't good. We really want to get rid of those duplicate tag reads. So again, I'm going to kind of skip on the details here and just show you how this works with making changes to the code. So when I create my queue, what I'm going to do is just comment in 2 lines of code here. And I'm going to specify that we want duplicate detection enabled on the queue, and we're going to have a time history window of 10 minutes for how long we store the IDs of these duplicate messages. Okay, so let's just run this again, and I'll drop up the everything's appearing on another screen here when I fire up the console application. So I'll just send these tag reads. So there, we got 12 tag reads, and in the receiving application, we have filtered out the duplicates. You can see that whistle was scanned twice. One of the pairs of gloves was scanned twice, but we've only got 1 whistle and 2 pairs of gloves appearing in the receiving application. Now, if you don't have duplicate detection, if you've ever had to build duplicate detection yourself in a messaging system, it's pretty hard to do. It can be a challenging pattern to implement. And there, it's just a switch. I've got to do that when I create my queue. Another thing that we've got is the concept of sessions. So in order to demo this, what I'm going to do is to just set the checkout console as a startup project. I'm going to run one instance of the checkout console, and then I'm going to go to the tag reader, set this as the startup project, and I'm going to run two instances of the tag reader application, and drop this one up here. Now, if I minimize Visual Studio, hopefully you can see these windows. And what I'm going to do is kind of simulate two customers checking out at the same time. So if I press enter here and press enter here, see that we've got two separate orders. And here we've basically got no kind of a control or no mechanism for figuring out which product is in which particular order. It's basically treating these as a group of messages. There's no way of grouping those messages together. So sometimes we would like to be able to send a group of messages and say these messages are going to be processed together. They're part of the same entity, part of the same business process, part of their items within the same order. And message sessions can allow us to do just that. So again, I'm going to drop back to RFID checkout. I'm going to go to the checkout console. And I've got a switch up here, use message sessions, because we basically receive and process the messages slightly differently when we're using sessions, and that just tells the application to use sessions when it is receiving. Also, when I create my queue, I'm going to say requires session is equal to true. And then in my sending application, what I need to do is generate a session ID for each order, which is going to be a new globally unique identifier, converting that to a string. And then before I send the messages, I'm going to set the ID of each message to the value of that session ID. And then it will basically treat all of those as being in the same session. Okay, so checkout is going to be the startup project. I'll run that console application, and I'll do the same thing again with the tag reader. Set this as the startup project and run two of those. And just minimize Studio. I'm going to do exactly the same thing. I'll press enter in this console and then press enter in this console. And here you can see we've got a message session in here, and we've processed those. We've got one order there for 98.86 for these 10 items. We've got the second session. You can see this was 1DD08, and that's was that this session? Was that correct? Oh yeah, sorry, 16DD08, and that's 16DD08, and then this one is E13BD439, E13BD439. So now we've basically told the service bus in a very few lines of code to be able to treat and process these messages together in a single session. So I'll round off on the service bus. We're really talking about eventing, but in event-driven programming, sometimes working with messages and working with the service bus is going to be a useful way to go. And we will be returning to the service bus a bit later on in one of the future demos. Okay, so I'm gonna. I was kind of scared. I got so many demos to get through, and it seems like it's quite short on time. But I'm gonna keep going and hopefully get through everything. I'm going to move on to event processing and a couple of different ways of working with events. Firstly, I'm going to cover working and treating the events as a stream of data. So in the taxi scenario, when you get the position of a taxi, really instead of that being its own individual event, what you may be interested in doing is processing the events as a stream, where you're basically, using this data stream coming in of where all of your taxis are and, how they're moving through the city. And by analyzing that stream, maybe you can get information about the traffic within the city. How fast is it to go down a certain street? How long does it take to get from this point to this point, based on the level of traffic that you've got within a system? So by doing this event stream processing, you're able to kind of analyze a stream of data and be able to gain insight into that. So that's one way of treating events, treating them as something like a telemetry stream. Now, with big data, You may have heard of this concept. You have data distributed maybe across many data stores, and you're basically selecting a value from a static data set. So this could be sales data, credit card transactions, stock transactions, viewers in social media, and so on. And you're gaining analytics on this static data set. Whereas with event processing, you basically assume that the size of the data set is infinite. And what you're really doing is selecting values from a dynamic data stream. So as the data stream is flowing through your system, you can basically run queries on that data stream and gain insights into that data stream. So if people are tweeting things about cloud computing, one thing you can do is query the Twitter database and run a large query on historical data. Or you can look at the real-time data, which will basically give you real-time insights into what people are tweeting. And this type of processing is very popular in telemetry-based scenarios. I'm not going to run through many of the actual definitions, but what I'm going to look at really is event stream processing a stream of events and trying to gain meaningful information out of it. And what I'm going to do is to basically spin up this application here. So what this is going to do is to take the CPU on my machine at the current CPU time, and it's going to send it out to Azure Event Hub. So you can see all of these values coming. This is currently my CPU time. So if I go into performance, and this is roughly the CPU that's running on my machine right now. And what I'm doing is I'm broadcasting this to an event hub that I've created within my Azure subscription. So we can browse in the portal to that event hub. So if I go back to the resource group for this session, we can see that we've got an event hub's namespace. And within that event hub's namespace, we've got an event hub, which is called perfmon. Now, eventually, we'll see these graphs starting to be populated. The number of, I don't like them calling it messages. They should really call it events, in my opinion. And we'll see the throughput. This isn't real-time data. It's delayed by a couple of minutes. So eventually, we should see some load coming on this system. But I'm sending, quite a significant event stream there. Now, what I would like to do is to be able to do some real-time processing on that event stream and generate an alert when the CPU on my machine goes above a certain threshold. So within the same resource group, I've created another service, which is called a stream analytics job. And this is called PC Telemetry Alert. Now, what this is going to do is allow me to write a SQL query on this, which is the actual dynamic telemetry stream that's running through. Now, to save a bit of time, I've already created the stream analytics job. I've said we've got an input, which is called telemetry, which is connected to the event hub. That's where the data is going. And then I've got an output, which is a container in blob storage, which is where I want to send out the actual alerts. So what I've got to do is to write a SQL query on that data stream there. So what I'm going to do is to select the, if I just look at the details of the event, you can see that I've got the name, the actual counter, and the value. Counter is always going to be processor time, so I'll just focus on the name and the value. So if I drop back to the portal, what I want to do is just select the name, and then the average value as put that in as average CPU. We may as well have the maximum of value as max CPU. The great thing about this technology is that if you've worked with SQL, if you've written a SQL query, you kind of understand what's going in here. I'm selecting the name, the average, and the maximum of those, and those are coming out as the average and maximum of CPU. Now, what I'm selecting from is telemetry, the actual input stream, and what I'm selecting into is going to be the output, which is going to be alerts. And we've got some of these red squigglies, and it's telling us that we really need to have a group by clause in this particular method. So what I'm going to do is to group by name. And we've got another red squiggly here saying exactly one temporal window is expected. Now, because we're dealing with events that are running over time, this is when it's going to get different from a regular SQL query. What I'm going to drop in is something called a hopping window. So it's going to be a tumbling window. And I think I specify S for seconds and then 10 for the actual duration of that window. Maybe this needs to be in quotes. Maybe I need to spell tumbling window correctly. Tumbling window, S, 10. Yeah, and it now seems to be happy. So what this is going to do is basically every 10 seconds, it's going to sample the average and the maximum CPU. Now this will output one event per user every 10 seconds. But what I can do is say having the average CPU being greater than a certain value. If we look here, you can see that I'm round about under 20% most of the time. So let's just stick it on to say 30. So if you go above 30% CPU, then it's going to generate that alert. So I think I can save that query and run that query. I should be able to start it somehow. How do I do that? Yeah, I close the job and click on start. Now it's going to take a couple of minutes for this job to start. So I might just drop back to that and run that as a demo just to save a couple of minutes. But takeaways from this is it's very easy to work and process this data. If you know how to write a SQL query, you can use Stream Analytics to do this kind of event stream processing very easily on a data stream. And looking in the Perfmon to Event Hub application, there's really not that much code here to actually monitor the telemetry and send it into the Event Hub and actually ingest that data. I think we should be able to see the data in Event Hub now if I refresh. It's still churning away. I was expecting to see some statistics there on that data. It is a bit delayed there, but hopefully it will pick up when we do get this thing working. Let's just see if it's going to pick up anything now. Nice, it's running a bit slowly, but I'll just check and see if the job is running. Oh, did I actually start the job? Yeah, so hopefully that should start satisfactorily. And oh yeah, you can see here we've got the events coming through here. We've got the actual throughput telling us that we do actually have data flowing in on that Event Hub. So another way of working with events is to work with real-time events. And this is going to use another technology, a separate technology, which is called the event grid. So I'll drop back to the slides. And I'll mention about the event grid, which is really built for working with HTTP based events. I always get Event Hub and Event Grid confused, so let's change that slide there. This is basically an instance of Event Grid. Now, Event Grid will integrate very well with other Azure services. So things that can publish events to Event Grid, we have things like Cosmos DB. When a document gets changed in Cosmos DB, that can generate an event. Media services, if you upload a video and you're getting the video encoded into various different formats, once that video has been encoded, once that's complete, an event has been generated and you can publish that video once it's been completed. I upload stuff to YouTube, so once my video has been encoded in various formats, it can then be published. If you're working with storages, blob storage and storage queues, they can generate events, as can things like the IoT hub, Azure resource groups. If you add and remove resources, that can generate events, and the service bus and the event hub. I ran out of space there. There's a lot more services that can generate events, act as event publishers, but I've just included those. You can also create custom event publishers if you would like to do that. You've got the option of generating custom ones. For the event consumers, we've got things like Azure functions. So an event can trigger an Azure function to execute. We'll be looking at this later on when we look at the serverless components next week. You could also trigger a logic app, which is a workflow that can provide integration capabilities. You can send it off to Event Grid. And you can basically work with webhooks as well, and integrate with other systems. A webhook is just an HTTP request that's going to go out to various other services. So you can very easily invoke an API or call some other service with these events. So for using the Event Grid, I'm just going to jump back quickly and see if my Stream Analytics job is running. Oh, it's still in the starting state, I think. Oh, it does say it's running now. So hopefully what I should be able to do is see if I can push my CPU above 30%. And what that should do is generate outputs in the blob container within this alerts container. So within the blob service, here we've got the alerts. There's currently no blobs in here. So what I'm going to do is just to fire up a few instances of Visual Studio. That should push my CPU above 30%. And it needs to be above 30% for about 10 seconds or so. I can hear my CPU fan spinning up. So I think we're getting this running above 30%. It needs to be above 30% for about 10 seconds. So let's just fire up a few more instances there. And I'll just refresh this blob container here. And you can see that we have got a JSON blob. And let's just see if we can open this. I've enabled public access on this blobs. So there we've got our data. And that's going to open up in another instance of Visual Studio. And you can see here that we've got these events where the average CPU was 35.6, 42.9, 46.9, and we've got the max CPU coming out here. So a nice way of being able to generate these events when we're getting a certain condition in a telemetry stream. Very useful scenario there. And I've done this using very, very few lines of code. Okay, so I think I need to close all of these Visual Studio instances that I've spun up there. Get those down to normal. So I'm finished with the topics and subscriptions. I'm finished with this demo. And I'm finished, I think, with the RFID checkout demo. And the last demo that I'm going to look at is the demo on working with the Event Grid. Now, what I've got in Event Grid is I have a, if I can just browse to the portal, within my resource group, I've got a website, which is this Reactor event viewer. I'm just going to scale this up a bit because you might want to actually run this website at home and basically see these events popping up on your instance of the web app. I think that might work. So what I'm going to do is to go to scale up. It's currently running on the free tier. So I'm just going to go into production and stick it on the S1 tier. And that will just give the web app a bit more capacity. And I'll see if I can go back to the resource group and go to the actual event grid topic that I have created here. So I'm actually going to delete this subscription here because I use this for testing. So let's get rid of that one. And what I'm going to be working with is events that are going to be related to trains. I'm also going to get rid of this train departures queue. Let's delete this one as well. And I'll show you the code that I'm going to be working with. So this morning I thought I really need something to actually show off how we'd use eventing in a scenario. And what I chose to do was to take train departures from Stockholm Central. And when a train departs, we're going to generate an event from that. So I found an API that can actually give us that information. And I'm calling that API and getting out a list of all of the trains that are going to depart from Stockholm. So this is the location of the API, and I make a call. Now, because the trains depart, once every few minutes, the demo isn't going to work too great, especially because I've only got about 5 minutes left in my session. So what I would really like to do is to have the trains departing every few seconds. So what I do is I basically say, okay, well, let's go from now. Let's get a list of the future departures, and we'll advance time each second. We'll advance the time 1 minute. And what we're going to do is just basically go through all of the trains and send out an actual event to the event grid every time a train departs. So if I set the event publisher as the startup project. I mentioned a couple of slides back, I was saying that, there's loads of different event sources that we can use for these event grids. And I mentioned, we've got all of these things, Cosmos DB. You can also generate custom event sources that can act as event publishers, sending these events out to the event grid. And that's what I've built here. So it's basically a train departure event. So what I'm going to do is to create a new event, and I'm basically creating this new event grid event. The subject is going to be train departure from Stockholm Central. This is the event type that I'm specifying, cloudcast.demos.trains, trains departure. And then within the data section, I can basically drop in the details related to the event. So we've got the train number, the departure time, the destination, the track that they're on, which type of train it is, which service it is, and then any comments associated with that. So if I start this, what this is going to do is to start sending out these actual train departures. So this is starting at, it's about 10 past 6. So this is the trains are departing, and it will basically run at 60 times normal speed, sending out the actual departure information and sending these out as events to the event grid. So right now, we don't have anybody that is subscribing to those events. They're just being broadcast. So what I'm going to do is to add on a couple of subscribers. So one of my subscribers is going to be this application. So if I go to the overview, it's going to be, where was it? It was the actual web app. So I'm going to drop this link here. And you can browse to this if you want. It's reactoreventviewer.azurewebsites.net, and I'll drop that in the YouTube chat. If you want to browse to that. Yeah, there was a couple of questions. Is this only available for web apps? What if I'm running IIS inside a VM? Yeah, so if you're working with Event Grid, I'm using a console application to publish to Event Grid. Yeah, so a web page in IIS. If you've got a public URL, you could use a webhook to send events so that website could act as an event consumer. By writing a bit of code, as I've done here, just in a regular console application, then you can publish events from a website if it is running on premise. It's just using an HTTP connection out to this particular URI. No, sorry, this is the actual URI there for the actual event hub. Sorry, the event grid topic there that I'm sending it out to. So you can use it either as a publisher or a consumer from .NET HTTP-based applications. They don't have to be running in Azure. Event format looks like a cloud events format. I've not worked with cloud events, but I'm assuming that all of these eventing technologies are very, very similar and share a lot of features and formats and so on. Okay, so this website is going to act as my event consumer. It's basically from Azure Learning. So if you do the Azure Developers courses, this is in one of the labs, and it's available as a Docker container. So you can just basically spin up one of these using a Docker container. And what it will do is display the events in this window as they are created. So I'm going to see if I can just resize this and drop this thing over here. And then I'm going to, I think I've stopped my little console application. That thing's not running, which is good. I can go to the event grid topic and I can drop on a new subscription. So this will be the departure board. And I'm going to use the event grid schema. The endpoint type is going to be a webhook. And the webhook needs an endpoint. And I've got the endpoints copy pasted in here, I think. Yeah, it's this thing here. So it's just /API/updates. So copy this, and I'm going to minimize this as I do it because it should actually generate an event when we subscribe to the event. So I'll confirm that selection and create that subscription. And you can see here that we've got this subscription validation event. So it's just saying here that we are subscribing to events. And now I'm going to run my little console application. So if I run this thing here, you can see we're getting our train departures, and we've got this train departure from Stockholm Central event here. We can go in there and we can see the actual details appearing here. This is the train, the departure time, the destination, track, and type, and so on. And each time a train is departing, we're getting another one of these events generated and routed to this particular web application. So you can also route to other Azure services. So what I'll do is I'll just stop this for now, and I'll go back to the portal, and I'll generate another subscription, and this will be for the train announcements. I'm going to add an event type, but sorry. Sorry, I'm going to, yeah, sorry, the endpoint type. This is actually going to go out to a service bus queue. And I'm going to select the endpoint for this. So it's going to be in the event-driven architecture service bus, not the RFID checkout queue. We'll go to the train departures queue, which is another queue that I've got. And I'll confirm that selection and create this. And that's generated another event subscription there. So if I go back to the service bus namespace, if I can find it, it's this one here. And then in the queues, we've got the train announcements queue, so train departures queue. And this is just a regular queue, and then I've got within this application an application that's going to do announcements. So I hopefully have the sound turned on because this is using system.speech.synthesis. And what I'm going to be doing is using the speech synthesizer to actually say out the announcement that the train is departing from platform such and such. This is going to be like an automated announcement that you have at the station. So I'm going to set both of these projects as the startup projects, and then I'm going to run this application here.
The train departing from platform 16 is the 1814 SJ regional service to Valsta in Kopping Vasteras Orbro Hallsberg.
Announcements going on in the background.
The train departing from platform 4 is the 1821 SJ Snabtag service to Gobel Soderham Hudiksvall Sundsvall.
Than they can be processed.
The train departing from platform 10 is the 1822 SJ Snabtag service to Linkoping Nasjo Alvesta Hasselholm Malmo.
Because it's a bit annoying. If I stop both of these applications and then go back to the train departures queue and just do a refresh, we're not able to process the messages fast enough. You can see here that in train departures, if I move along to the queue properties, we've got 6 messages here that we haven't processed. So one of the things I can do when I'm receiving and processing the messages from the queue in the announcements console is do this multi-threaded. Currently, I'm doing this single-threaded, but if I want to do this multi-threaded, when I generate my receiver, I just specify that the maximum concurrent calls is going to be equal to, say, 30, which means we can have 30 concurrent receive threads running off this service bus queue and processing the messages. So let's just run this thing again.
The train departing from platform is the
So it's picked up quite a lot of these messages because we have those 6 ones on the queue. Every time a train is appearing,
the train departing from platform 3
departing
is the
messages.
1837 SJ regional service to Marsta Uppsala. The train departing from platform 198
and if you're from Sweden, you're probably laughing at the pronunciation.
regional service
This is basically how I spoke Swedish when I first moved to Sweden. It doesn't really understand the Swedish vowels.
The train departing from platform 13
but you could,
is
if you wanted to
1855
use the event routing, because you've got a publish subscribe architecture. If you had a station with many platforms and many different tannoy systems, you could say, well, let's route these messages to the appropriate platform based on the actual platform announcements. So the departure board and the actual announcement would go on that particular platform across a large station. So you could combine the publish subscribe messaging with the event processing to do just that. So I've really run quickly through these technologies. I think each one of these technologies, we could do a full 60-minute session on each one of those particular technologies. So hopefully it's given you a bit of an insight into what these technologies can do and when you may want to use those technologies. Just as a very quick recap, I'll just whiz back to the slide that kind of highlighted these 4 technologies that I mentioned. And I said that I wasn't really going to talk too much about storage queues because they're very basic. I demoed the service bus. I used it for the publish subscribe, for publishing, subscribing the order messages. I used it for the RFID checkout, and I used duplicate detection and message sessions in the RFID checkout demo. I then went on to Event Hub, and I used that for my PC telemetry in a telemetry scenario combined with Stream Analytics to generate the alerts. And then I used Event Grid for the train announcements to be able to take the HTTP requests and route those out to the actual destinations. Final thing on Event Grid before, I think I've got a couple of minutes, so I'm just going to whiz through this demo really quickly. Apologies if I'm running over time, but there will be a bit of time for questions. We can also link other Azure services as publishers. This demo is so quick to do, so what I'm going to do is to go to my storage account. And within the storage account, you can see we've got events. I can generate a new event subscription, and this will be new images, and the event type is going to be a blob created, I think, and the endpoint type is going to be a webhook. And the endpoint is going to be the same one as I was using in the other demo. So it's this one here. Like that. What that should do now is generate events when stuff is uploaded into blob storage. So you can see we've got this new event created there. So what I should be able to do is just go to my storage account. If I go to the containers and then go to the images, and then let's upload some images and browse down, and I'll take, these are the spectrograms that I was doing when I was doing the audio analysis, but they'll do for loading up. And let's upload those images. And they get uploaded into blob storage. And each time one of those is uploaded, we get those blobs created events there. And you can see that we've uploaded an image. You can see all of the details about that particular image there. So very easy to generate events from other Azure services and have applications subscribing to those events. Okay, so that's about the end of the session. Please do type any information in the YouTube channel. I'll just go through the questions. Do you have a cheat sheet to show which case is best suited for which type of technology and architecture? Not really an overview. I haven't really seen anything online talking about that. But there are some great sessions on that. I'll see if I can find that session because there's this. It's by the Finland Azure user group. And the session was by a friend of mine, Dan Rosanova, who used to be the project manager for all of the eventing technologies. And he's basically done this video here. Is basically Azure messaging, when to use what and why. So he talks through all of those different technologies and gives you really detailed view. He's more heavy on the PowerPoint than the demos. Let's see if I can find the, I've lost the window here. That YouTube session there basically goes through a lot more of the theory. It's not really maybe a cheat sheet, but that talks about the scenarios of all of those and gives a lot more theory on the actual eventing technologies. Okay, so I'll just drop on to the final slides. If you are located in Stockholm as compensation for not having very much daylight, you can go and subscribe and get some free stickers. We'll send you some of those to say thanks for watching. And thanks very much for taking the time to come and listen to this session. We've had the intro by Chris Klug, which is out on YouTube, and then this session by myself. I'm going to be talking less about plumbing and more about services next week. I'll be talking about Azure functions and logic apps and how we can build serverless architectures. But serverless architectures are very mainly going to be event driven, so we'll be taking some of those concepts that we had this week, and then we go into working about containers and Dockers with Chris and Jakob giving some great presentations on how to work with a container-based deployment. Thanks very much for listening. I will be around if anybody does have any questions. Please feel free to type them in to the YouTube chat.
Thank you, Alan. And I love how you do my job as well, introducing the next sessions.
Yeah.
You guys did that last week as well. But actually, did you want to drop a link in the chat to answer the last question? Or what was it that you wanted to share? Because I don't see it.
Yeah, I tried.
I think drop it to me in the private chat, and then I think it's an admin thing. And I think you can't share it via StreamYard. So drop it to me, and then I will share it with you.
Yeah, I'm doing that now.
Okay.
Yeah, the Azure messaging, when to use what, because I actually see it in the chat, but for some reason it's not coming out. Maybe I've been blocked or censored or something.
No, I think it's an admin thing.
Yeah.
But now I have just put it in the chat. So there you go, guys. So yes, thank you once again. And yeah, you guys who is still watching, ask your questions now if you have any. Otherwise, we are going to wrap up this session. And yeah, I just wanted to say another big thank you to you, Alan, and I'm very much looking forward to see you again next week. Twice, actually.
Yeah.
Both on Tuesday and on Wednesday.
Yeah, it's going to be machine learning theory on Tuesday and then serverless architecture on Wednesday. Yeah, so my evenings are busy next week.
Yes, indeed. I see you more than my own husband, probably. But so yes, guys, next week we are going to, oh no, that's wrong. Sorry. A machine learning theory on the 1st of February. Sorry, that session, this is an old slide, I should have updated. So that session is being replaced with another one, which is machine learning theory, and that's going to be presented by Alan as well. And then we have even serverless architecture in Microsoft Azure, as Alan just mentioned. And then in the DevOps track, we have tomorrow the GitHub intro code spaces with Magnus from last week. So please make sure to sign up on your local meetup group to receive the link to view. But yeah, any more questions? If not, no more questions, then as I said, we're going to wrap it up. Yeah. No? Okay, I actually have one question to you, Alan. Meanwhile, the guys are hopefully putting something there. So yeah, as you know, the series is for beginners, for students, and for those who are starting off with their developer career now. Do you have any tips or anything that helped you throughout your career to get you where you are right now? Anything that you've practiced or anything that you've done?
Yeah, I was learnt by coding. And I've always tried to stay kind of a step ahead of everybody else and focus on something new. So at university, everybody was programming in Pascal. So I decided that I should learn C when I was at uni. And so I think I was the only C programmer on sort of my year. We were all electronic engineering courses, and everyone was fighting with Pascal, and I was fighting with C. It was challenging, but that got me into working with programming. And then I was an early adopter of Java. And when I was working at a company where everybody was working with C, I was working with Java. And they all thought it was strange that, Java will never take off. Everything's going to be written in C++, blah, blah, blah. And then when .NET came along, I kind of adopted .NET as early as possible. And then with Azure as well. I remember working with Azure in 2009 and trying to teach courses in Azure, and nobody was interested. And it really took until 2012, I think, before it started to become popular. So now I'm looking at AI and machine learning. I know that's been around for a lot in other technologies, but it's something that Microsoft is really starting to put a lot of energy now and embrace. So I think if you're going to be working with Azure, I would recommend looking at the core Azure technologies. Service Bus is probably one of the core technologies. I'd say Event Grid is very useful. Event Hub is maybe a bit niche. And then things like Azure Functions is going to be good to look at. Working with the Azure Cosmos DB as well, that's a great service to work with. And just kind of try to learn. You can't learn everything in Azure. There's just too much stuff to learn, but just focus on some of the core services and also what most interests you. Any recommendations for an event store? The Service Bus actually stores its events durably. So basically, with the Service Bus, the events are being stored durably. With the event hubs, you can actually configure persistence on the event hubs. So they will basically push the data down into blob storage, I think, or Azure Data Lake. So that will basically act as a storage mechanism that's basically built into event hubs. So I'd just recommend using Data Lake or blob storage, I think, on event hubs as the actual event store, and that's built in. And it's just you enable it and you click just click a checkbox and configure it, and it will do the storage automatically for you.
Thank you for that answer. For both answers, in fact. Yeah, I think we have no more questions. Then I'm going to let you go and enjoy the rest of your evening. And I will see you, Alan, next Tuesday. But yeah, once again, thank you so much for joining us today.
Great. Thanks for the opportunity to present.
Yeah, it's been great. And you guys, I probably see you tomorrow at DevOps Thursdays. If not, I will see you next Wednesday at Cloud Native Wednesdays. Have a nice day or evening, wherever you are in the world. Bye.
Great. Thank you for listening as well. Thanks.